Hello, thank you for watching this video on the principle of mathematical induction. Now let's see what the principle of mathematical induction means. Mathematical induction is a technique of proving a statement, a theorem or a formula which is thought to be true for each and every natural number n. There are some steps involved in this process and they are: 1 is to prove that the given statement, which we may denote as P of n, holds true for the initial value n equal to 1. The second step is to assume that the given statement P of n is also true for n equal to k, where k is any positive integer. Then the third step is to prove that the result is true for P of k plus 1 for any positive integer k. If the above conditions are satisfied, then we can conclude that P of n is true for all n natural numbers. Now we will look at some examples. We have about 3 examples to illustrate this principle. So please come along with me. Let's learn together. Example 1. Use mathematical induction to show that 1 plus 2 plus 3 plus up to plus n is equal to n into n plus 1 over 2 is true for all positive integers n. Now let's start the proof. We will denote the given equation by P of n, and then we will show that P of 1 is true. You will agree with me that when n is equal to 1, the left-hand side is equal to 1, and the right-hand side is equal to 1 times 2 all over 2, which is also equal to 1. Therefore, P of 1 is true. Next, we will assume that P of k is true. That is, equation P of n now becomes P of k. So if we assume that P of k is true, then we will obtain P of k plus 1. How do we get P of k plus 1? We simply add k plus 1 to equation 1. Having gotten equation P of k plus 1, we simplify it to arrive at k plus 1 into k plus 1 plus 1 all over 2. And this shows that P of k plus 1 is true. So we conclude that since P of k plus 1 is true, then by the principle of mathematical induction, P of n is true for all positive integers n. The second example is to prove by induction the Moravia theorem that cos theta plus I sin theta all raised to power n is equal to cos n theta plus I sin n theta for every theta in R and every n in the set of natural numbers. Now the proof. Let theta in R be fixed and let P of n denote the given statement. Then we can clearly see that P of 1 is true, since if we insert 1 in place of n in equation 1, we will obtain cos theta plus I sin theta. If we assume that P of n is true, so that cos theta plus I sin theta all raised to power n is equal to cos n theta plus I sin n theta, then P of n plus 1 will now be cos theta plus I sin theta all raised to power n plus 1, and that is equal to cos n theta plus I sin n theta multiplied by cos theta plus I sin theta. That will be equal to cos n theta minus sin n theta plus I into sin n theta cos theta plus cos n theta sin theta. The result is cos n plus 1 theta plus I sin n plus 1 theta. So that means P of n plus 1 is true. We can now conclude that by the principle of mathematical induction, the given statement, which is the Moravia theorem, holds for every n in the set of the natural numbers. Now, the third example, consider the sequence x1, x2, x3, and so on, given by x1 equal to 5, x2 equal to 11, and xn plus 1 minus 5xn plus 6xn minus 1 equal to 0 if n is greater than or equal to 2. That is statement I. Then we want to prove by induction that xn is equal to 2 raised to the power n plus 1 plus 3 raised to the power n minus 1. That's statement 2. For every n in the set of natural numbers. Now the proof. We let P of n denote statement II. Then we can see clearly that P of 1, P of 2 are both true in statement II, since x1 is equal to 2 raised to the power 1 plus 1 plus 3 raised to the power 1 minus 1, which is equal to 5. And x2 is equal to 2 raised to the power 2 plus 1 plus 3 raised to the power 2 minus 1, which is equal to 11. Now, if we assume that n is greater than or equal to 2, and P of m is true for every m less than or equal to n, so that xm is equal to 2 raised to the power m plus 1 plus 3 raised to the power m minus 1 for every m less than or equal to n. Then, to get P of n plus 1, we have xn plus 1 is equal to 5xn minus 6xn minus 1, which is equal to 5 into 2 raised to the power n plus 1 plus 3 raised to the power n minus 1 minus 6 into 2 raised to the power n minus 1 plus 1 plus 3 raised to the power n minus 1 minus 1. If we simplify that, we will arrive at 2 raised to the power n plus 2 plus 3 raised to the power n, which implies that P of n plus 1 is true. Therefore, it follows from the principle of mathematical induction that statement 2 holds for every n in the set of natural numbers. We're going to end the video here. I hope this video has been beneficial to you. Please subscribe to this channel and like and share our videos. If you have any comments, feel free to leave them in the comment section. Thank you for watching.